Hey everyone, in today's video we're going to talk about events. So in CyFlex, the two most fundamental concepts to understand are events and variables. So today we're going to go over one of those fundamental concepts. So for starters, what I recommend doing is going to CyFlex.com, Help and Docs, CyFlex Manuals. That'll get you to this page. Search event, and then there's two documents, CyFlex Events. This is an overview of how events work in CyFlex, and then there's the event response utility. The event response utility, often just simply referred to as event response, will read the ER specs file, the event response spec file, and that's a program that's dedicated to doing nothing but listening to events and then configuring them for whatever you want to do for your specific use case. So these are great documents. This video is not a complete supplement to everything that's covered in these documents. So whenever you're new to CyFlex, these are definitely high on the list of documents that you should read. So there's a couple lines in this overview that I think are worth simply reading to do the high-level overview of what events are. And one is this first sentence. An event in CyFlex refers to a method of communicating and signaling between processes. So events are the way that when you launch CyFlex, you're launching 10 to 400 programs in your Go script. And events are one of the ways that those programs communicate between each other. I would say they're probably the primary way. They have names which are alphanumeric strings. The rest of this paragraph gives you some rules about that, but this is the next sentence worth saying. When an application sends an event, it could be received by one application, by multiple applications, or none. The one or multiple, that's the big thing to kind of focus on. So you can create a user event a variety of ways. We'll go over those ways of creating them, but you can have GP test listening to that event, as well as event response, as well as Flogger. There's many different programs can simultaneously be listening to the same event to do things. So this is the event response utility document. Again, this is probably the primary thing that people think of whenever we talk about CyFlex events, because this is where you're going to configure your user events, and more so, you're not going to create those events here. This is where you're going to configure what happens whenever they get set. Let's start by just triggering an event real quick. So there's this command called events. If we look at the usage, it's a program that you can launch from the command line to monitor CyFlex events. What's happening when you type this is you are attaching to that event. That's going to be the terminology that you're going to hear a lot of people use. The other way of kind of saying it is that you're launching a new program that is listening to the event. So I have this event, I think, on my system called test event. And so the way that you use this command line tool to monitor events is you start by typing events. It gives you instructions. You can give a list of events. In my case, I just gave one, and then when you hit period, you indicate to the program you're done giving it events to listen to, and then now it's just sitting and listening. This is this process. I know there's a bunch of other stuff going on here, but so I've got a program now running in the background listening for this event. Set EV is it's a command line program you can use to set events. You can call this from a script, or you can just do it from the command line. So if I do a use on set EV, it's fairly straightforward. You type set EV and then you give it an event name. So if I do a set EV test event, then this events program shows me that this event name with this event ID was set at this time by this process ID. Now, setEV is a process that's going to launch and then exit. So if I were to do a pgrep on this, it wouldn't return anything now because this program started and has finished its job and left. But if the event were set by GPTest and I still had GPTest running, then this PID would be the instance of GPTest that set that event. So that can be useful in diagnosing who's doing what sometimes. So, yeah, that was a quick, simple demonstration from the command line of setting and listening to events. How do we create events? Well, there's a lot of different ways that you can create events. One super generic way is in your gen labels file. Towards the bottom, there's an event section. You simply type an event and it gets created. So I just put this down here, and let's see if it exists. My dummy event. It does, because I put it in here and I just ran a go. So if I put a second one in here, save the file, let's say my dummy event 2. Events is giving me an error that says the specified event could not be found. So why can it not be found? I already saved my file. Well, I have to essentially tell CyFlex that I've changed this file. I do this by typing gen labels. This is my default gen labels file on my system, so I don't have to give it a full path. Now if I type my dummy event 2, you see it doesn't give me that error. Now it exists. So now I'm listening to these events. I can do a setEV on my dummy event or my dummy event 2, and you can see that those events exist and they can be attached to by other programs. So that's one way that you can create events. Another way is through logical variables. I probably shouldn't have closed that file. So when you create logical variables, there's a true event, false event. So let's kind of see how those work. These are called transition events. Somewhere in this document it talks about the difference between just user-created events, signal events, and transition events. Transition events are attached to variables and they get triggered whenever that variable changes value. So they can be attached to, I know that they can be attached to logicals, and that's mostly their use case. They can be attached to integers. So let's look at a logical case. So I just have this test request variable, and I've got these events tied to it. So if I try to monitor these, and I say test request, test off, you can see they both exist. And so in this case, I'm not going to use setEV. I'm going to gvar test request, and it says it's off. So the true event gets set whenever I change this variable from off to true, whenever it transitions from being 0 to 1, false to true, whatever. So if I now svar this on, you can see that I triggered the test request event via svar. And so I didn't, in this command, I didn't actually, I didn't type this actual event name. This event is associated with this variable, and whenever that variable changes values from false to true, it's going to set. Whenever I switch it to off and it transitions from true to false, then the false event is going to be set. So that's an example of a transition event. So in addition to logical variables being able to trigger events whenever they change value, integers can as well. And so I'm just going to throw a event in here called we'll call it int trans event. And so then I will run gen labels, and then I'll put int trans event in here, so you can see that I just created this event. And so now whenever I change this variable's value, that event goes off. And so it doesn't matter what I change this to, the same event goes off. And so you can configure this if you've got integers that every time they change state, you want certain things to happen. You can use this. Now, oftentimes, the things that you want to happen might be based on some GP test with a switch statement that says, well, what actual value did it change to? But the event gives you the ability to essentially constantly be listening for that state change and then immediately do what it is you need it to do, that value checking after it changes state. So that's an example of an integer. There are other files as well. So let's look at input specs. So in input specs towards the bottom, we've got our digital inputs. These also have a true event and a false event. And so these are going to work identical to a gen labels logical variable, where if they change values, it's going to trigger events, except now you can have them triggered based on things in the physical world, such as digital inputs that you're reading in. Another example would be DO specs. So if you look at DO specs, whenever you're creating these logicals, oftentimes it's going to be CyFlex that's actually changing these, but it might be the case that every time, like let's say the key switch is on an operator display and you want certain things to happen every time the operator turns that key switch variable from off to on. Well, you can actually use these events to configure your system to do those certain things and perform those checks. So those are some of the, oh, and then the other one I put in here is flogger. So if we specs.def, flogger spec.def, and search, yeah, it's already here. So the start event and stop event. So these are other events, you know, when you launch Flogger and you've got it just running in the background but not logging. The start event is how you're going to tell it start logging, stop logging. The release event is going to be how you tell it to completely go away. If you've modified the file, you can use this release spec file event, and Flogger will actually create these events, which it, you know, details here. And the same, you know, before I had input specs and DO specs open, those will create events. So there's a lot of different programs that can actually create these events, and then most programs can be configured to listen to the events as well. So these are some of your more common user events. I could go on and on about these, but I'll just leave it at that for now. We'll exit out of that. We'll clear our terminals. So another thing that we have are timer events. So this is kind of a fundamental principle of almost everything in CyFlex is timer events. So on my system, if I do a send -p on scheduler, you can see that I've got this warp event timer, fast, medium, and slow event timer. If I look at my Go script, this is how I launched it. It looks almost identical to the send -p output, and this is on your system. This is more than likely, almost certainly going to be where you're going to find it. When you go test cell to test cell, system to system, you might find that different systems are configured with different timers. And so sometimes I get on a system and fast, or FAS, is equal to 10. So these are generic, I guess you can think of them as like aliases, where you can reference in other spec files like gen labels. Tab didn't save me on that one. you can just reference timers under your interval or event. So here you can see I've got warp. So I want to update this variable at warp. Well, this is where warp is defined. Warp is defined to be 10 milliseconds in my Go script via my scheduler call. So an important quick thing to note on these other timers, whatever your fastest timer is, whatever your warp timer is, all your other timers need to be a multiple of that. So you probably shouldn't put 7 as your warp timer. Most commonly I see 10 for warp or 2. Sometimes I've seen 5. The event administrator won't really allow you to do anything faster than a 1 millisecond timer. And in general, unless you've got a system that's only doing a few high-speed tasks, I don't recommend running it that fast. It struggles. But so, the scheduler is creating these generic strings that are associated with certain timer intervals that you can then launch your programs as. So if I look at my Go script, there's going to be many references to those timers. Let's just jump further down. Whenever I'm starting comp bar, here I'm telling comp bar that I want it to attach to the warp timer event, fast timer event, medium, and slow. Ideally that means that I have at least one variable in that file configured for all those timers. So the question is, what does that mean? For me, the easiest way to demonstrate this is using events. So again, send-p scheduler, we'll pull this up so that we can kind of reference why I'm doing what I'm doing. All of these are going to create an event that's called TMR dash and then whatever this integer is. So if I put TMR dash 1000, that's an event that's created because I put 1000 to be equal to slow whenever I called scheduling. So if I monitor that event, you can see based on these timestamps that about every 1000 milliseconds, the event administrator is triggering that event. What that means is that at 1 hertz, or every 1000 milliseconds, that event is going to go off, and every CyFlex program that is attached to that event is going to do what it's told it's supposed to do when that event goes off. So comp var is going to update this variable to this value every 1 second, because I put it here, and because when I launched comp var I told it to attach to that slow timer. So that's kind of what's going on in the background as far as how almost everything in CyFlex works from a timing perspective. All of these events get created when you run a Go, and then all your other programs, most of your other programs, attach to those events and do what they're programmed to do whenever those events go off. There are a couple nuanced programs like AI transfer that are a bit misleading on that, but we'll maybe dig into that later. So these are timer events. Let's look at some others. So if I do events on timer 100, you can see I got a lot more events firing off. And if I count the time in the, I guess, millisecond value, they're about 100 milliseconds apart. 523, 423. That's good. You're going to notice it's not always perfect. There are going to be a few, what would that be, microseconds off. Yeah, that's just how it works. So this is a faster event. We can go even to our fastest and say events timer 10, and now we can see that it's just raining down the screen and still around 10 milliseconds apart. So yeah, the real importance on timer events to know is basically all your programs are being triggered on these timer events, anything that's attaching to a timer, if you've heard that terminology before. So if you've got certain calculations that you just want done on timers, then this is how they're working. underneath. Let's see. So that's kind of an overview of timer events. Other special events worth going over. So there are some core CyFlex applications that were written that are, of course, specifically oriented towards engine test cells. Programs like CellMon, the cell monitor. So although CyFlex can and has been used very regularly to control things other than test cells, at its core it was a test cell control automation suite. So there are these CellMon programs that are kind of hard-coded to look at these certain events like abort limit and event response, and emergency. In general, you're going to see a lot of systems configured so that they're really focused on these events. You're going to see abort limits all over GP test, all over event response, and in your limit specs file. The kind of core programs that are keeping the test cell safe are all going to be listening for these abort limit and emergency events. And we talk about those events a little bit in this document here on events, I believe. Yeah, the emergency event and then the abort limit event. So, I believe CellMon is even going to generate errors. Set EV abort limit, and then if I do an ERS on P equals CellMon, yeah, you're going to get an entry in your error log every time an abort limit is set if you've got CellMon running, because CellMon is just hard-coded to always be listening to that event. So those are a couple special events just to quickly touch on. We'll dig into more detail on how you're going to use those later, but it's worth mentioning those are special. The other one is in your cell directory. You're going to have this, I'll open it up in code, logispecs file. And so you probably should do what it says at the top and not modify this file. These are a list of special CyFlex variables that are going to be attached to special events that other programs are hard-coded to listen to. So, I mean, these are a great example that are, again, test cell specific, but used a lot whenever this is a logical variable that's going to be created that pretty much any CyFlex system, any test cell you go on, you can gvar this variable and you're going to find it. But more importantly, there are these events, maybe not more importantly, but also importantly, there are these events attached to this variable that you can often use to trigger maybe a GP test that's waiting for the engine to start. Well, you can have GP tests say, well, once the engine's over 1,000 RPM, I want it to do this. This is actually the more common one used for your GP idle to know whenever you to transition from the wait mode from when you're just waiting for the engine to start to the my engine has started mode of your GP test. So once they shut down the engine and GP test knows the engine's shut down, you can just listen for the speed greater than 400 as a transition event to know that you need to go to your actual mode that's configured for when the engine's running. So there's plenty of other examples in here specific to things like hour meters and other things. So yeah, these are some more special events that exist. Yeah, and so next we'll get into the event allocation. So to talk about event allocation, we need to look at the usage for event administrator. So if we just first of all send -p event, yep, CyFlex is still running. Event administrator was called and it's got these two arguments. So let's look at what they are. Use event administrator. So event administrator gets called. This is something that's launched relatively early in the Go script. The max number of events is optional. I didn't realize that until today. So this is where you specify how many events you want to be created. The default is 250, and clearly that's very old because I don't think I've ever been on a system that only has 250 events. Timer resol. It sounds like a resol cart. The timer resolution is going to basically be what is the fastest timer that it's going to be capable of firing. So in our example, we've got an example of someone launching the event administrator to create 200 events, and it will fire as fast as 5 milliseconds. So this is an important thing to note. Earlier we were talking about the scheduler, and I mentioned that these timers need to be a multiple of your fastest timer. Well, your fastest timer needs to be equal to or slower than the timer resolution value in your event administrator. So if you had your event administrator launched like this, it's only going to fire events as fast as 10 milliseconds. So if you were to then configure your warp timer to be equal to 5 milliseconds, it wouldn't work. It wouldn't fire events at 5 milliseconds. I don't know how it would fail, but it would fail. So you, as the end user, need to be conscious of the fact that if you're changing your fastest timer event, you may also need to change your event administrator timer resolution. At a bare minimum, you need to double check it. So after we've launched everything, we've got the event administrator running, and we've created all these events and allocated the memory to say we can have up to X number of events. How do we know how many we actually have? There's a command for that, show memory. And then you kind of scroll down to this line right here. So just to put this on the same screen at the same time, I launched Event Administrator and I said create 15, or well, what I'm actually saying here is allocate enough memory so that I can, as the end user, create as many as 1,500 events. After I ran my go, my system is only actually configured to create 303 events. So when you run show mem, it's going to tell you how your memory is allocated in a lot of ways, and one of them is the events. And so my system, I'm using 20% of what I've allocated, 303 of 1,500. So if I wanted more memory, I could, on my system, without a doubt, I could change this from like 1,500 to 500. It's always good to give yourself some buffer because you may end up on the fly, you've got some tests coming in and you have to make 10 events. If I were to reconfigure Event Administrator to create 303 events, then the next time I tried to create a new event, it would fail. And so you don't want that. So yeah, that's how you see your event allocation in memory. Yeah, and so that's how you allocate events. So next we're going to talk about setting events. So I kind of jumped the gun, because for me it's easy to demonstrate. One way that you can set event is from the command line, using the set EV command. Another way are transition events. We already went over that with logical variables and integer variables. Another way is from an operator display. So I've pulled one up. There's let's see, what's it called? The CyFlex event button. So when you open up Designer and you're adding widgets to your display, one of them is the CyFlex event button. And so with that, you can put whatever string you want to be on the label, and so that's what the operator is going to see. But what's more important is we're going to tie that button to this event. So here's an example where I've got level up and level down, and then I've got this level variable. So I can click this button and you can see that level changed. And when we look at the properties again, the event is E level up. So let's attach to that event using events. So now if we come over here and we click this button, we can see that that event was triggered by run QTUI. And it was triggered because I pressed the button. So in this case, events is attached to this. The other application that's attached to it at the moment is event response. And so if I search E level up in here, we can see I've got this simple configuration and event response that says whenever I receive the input event E level up, I'm going to use this app parameters, which is a keyword we'll get into deeper later that you can use with ER specs and event response. I'm going to change the level variable to be equal to whatever its current value is plus 1. And I also have one for E level down, and that changes it to minus 1. So what happens, so like, I guess to see this, if I do a gvar on level, you can see that it was modified by event response at this time. And so that was, whenever I clicked the button a little while ago. So if I bring this over here and I level it down, and then I gvar it again, you can see a little closer to this timestamp, a little after, it was updated to 2, and it was done so again by event response. So that's because event response is attached to this event. It's always listening for it to be triggered, and when it gets triggered by any other application, whether it's run QTUI or GP test or whatever, it's going to do what I've configured it to do, which is change this variable value to this. Another place is GP test. That's another very common place. So if you do a look at GP template and you do a search for set event, this can be another way that you do it. You can be in the middle of your GP test and you can be waiting for certain things to happen, and then you can say, okay, once those things happen, set this event. And so in this case, if I wanted to change the level variable to 1 higher than it currently is, I could call at set events in my GP test to E level up, and it would increment that up by 1. And so event response is doing the incrementing. GP test is telling event response when to do the incrementing. Another quick example is going to be limit specs. Again, I've trusted tab too much. So screwed that up again. Let's try it for the third time. So limit specs, I'll probably need to do an entire video on this, but this is another application that can trigger events depending on variable values. So let's come to a simple one. If the exhaust port 1 temperature goes higher than 13 degrees Fahrenheit, then I'm going to trigger this flag limit event, assuming it does it for more than 0 seconds. So that's just a quick demo. There are many different applications that can be attached to and set events. GP test being one of them. Set EV can be done from the command line. You can do it from an operator display. The possibilities are almost endless. So the final thing that I wanted to talk about as it pertains to events is event response. So a dedicated video could and should definitely be made for event response, but I'm just going to go over some basic examples here. I'm going to talk about how to start it, because this is the primary utility that you're using whenever you want to do a certain set of things anytime an event is triggered. So in the case of like GP test, you might have a wait mode that you listen for an event, and when it gets set, you go do something. But then if you're not in that listening mode, maybe it doesn't do it. Of course, there are global events with GP tests, but we'll get into that later. This is a program and a spec file that you can launch and then configure to just always be listening for certain events, and every time that they get set, do certain things. So first of all, let's quickly look at the usage. So event_RSP is the name of the program, event response. So you give it a registered name, priority, interval, and then you can launch it as critical. Most test cells are going to have at least one instance running as critical, because there's a lot of safety related things in this that this program handles, and so if it stops responding, you don't want to you want to trip the watchdog. So the other command is ER_specs. ER_specs is how you tell that instance of event response what you want it to do. So over here, we've got a registered name of event response. If we look at our Go script, I must have typed that wrong. We've got event response started here, priority of 15. It's attached to the slow timer, and we've got it running as critical, and we launch it in the background. So this is us launching the program that hangs around, and then later on we've got ER_specs getting called down here. We didn't give it a file name. There is a default file name like many other CyFlex applications. .nnn is going to be what's in your cell name in cell. So yeah, quick glancing overview of starting the program. We're going to just step through a few simple examples of what it can do. So this first example, I'm going to run events and then abort limit, so we can monitor the abort limit event as we do some of these things, because that's what I've got as the output event in some of these. So the keywords that you're always going to see for every little sub-configuration in this spec file are at input event. This is what event response is going to listen for. Then there's going to be a body, which is everything that you're going to do when you receive that event, and at end, indicating that you're done configuring what you want event response to do when it receives that input event. In this case, we're just triggering this output event, abort limit. So what this is saying is every time test event gets set, we're going to trigger an abort limit, period. So if I do a set EV of test event, we see that we trigger an abort limit up here, and it was triggered by event response. If I do a sim -p on event response, we see this process ID should match up with this process ID. So that's a quite simple example. More often than not, you're going to have some conditionals in your setup, because you're going to want to do certain things. Maybe you want to only set an abort limit if the engine's running. So in that case, you could say, let's check the value of this logical variable. And here, instead of at output event, we have at pass output event. That means we're only going to set this output event if our conditional keywords, so at if true or at if false, pass their test. So in this case, if test logical is true, then we're going to set the abort limit. So let's gvar test logical. It's currently off, which means if I set EV test event 1, I don't get an abort limit triggered up here. This one is from earlier. Let's just demonstrate that again so it's clear. But if I change test logical to true, and then I set the event again, I do get the abort limit. So event response is going to check these values. You can also have computed expressions in here. And then when you look through erspecs.def, you're going to see a lot of different keywords that exist in their base form and their what I'm going to call conditional form, which is that if all the conditionals you threw in there, then we can do an at pass or an at fail. So let's move on to more conditionals. So in this case, not only does test logical need to be true, but this speed greater than 400 needs to be true. So let's see what this is equal to now. It is currently true. I'm going to run my stop your engines script, which is going to make it false. This is just something on my system. You won't have this. I don't have an engine here, so I have to do some things like that to make these work. So now if I set test event 2, if I set this input event, it's going to evaluate both of these, and unless both of them are true, we're not going to do this abort limit. So let's set EV test event 2 as expected. Nothing happened up here. Now let's quickly get into this at if fail display. This is a keyword specifically to help you troubleshoot why event response didn't do something that you maybe wanted it to do. And what it's going to do is update the notify, well, it's going to update whatever string variable you put in here. In my case, it's notify, and that's often going to be the case because often you're going to have the notify variable in a special spot on your operator display so that even when you're thumbing through your other tabs, it's always there and the operator can always see it. So what does this say now? Test event 2, event response action due to speed GT 400. Yeah, could we be more cryptic? That can be a little confusing at first, but basically what it means is there was an if true in my after my at input event that had a logical variable, and this is saying that the value of that logical variable caused me to not do what was in your at pass whatever, at pass output event, at pass parameters, etc. So in this case it's relatively straightforward, but the point of this is so that you can diagnose which of your conditionals, because I think you can have up to like 64. It says in erspecs.def, but you can have a lot of variables on these conditionals. And so you wouldn't want to have to look at a display or gvar all day figuring out which one is causing event response to do what it's doing. So that can just put it right in your face on the operator display. So now if I change the value of speed GT 400 by running my start your engine script, and then I set this event again, now I've got an abort limit. So again, I set this event, test logical and speed GT 400 are now true. Just to show you I'm not making that up. That happened from my start your engine script that I ran. So yeah, now let's get to a somewhat confusing part. We come over to my notify variable and it still says the same thing. It says, yeah, test event 2 on the left, it's showing what was set, and then it says speed GT 400. Well, that's because I never configured anything to update the notify for when it's successful. So I'm updating this string variable when I fail, but I don't have anything configured in here to update it when I'm successful. So it kind of has this stale value. So down here, I put an example where I actually did update the notify for success. And then I added yet another conditional. And this is to illustrate that you can have if trues and if falses in the same input event. So what we're doing here is when we receive test event 8, we're going to check to make sure that both of these are true and this is false. But here we've got at pass and at fail actions. So we're going to do something no matter how these conditionals evaluate. We're either going to do execute these commands or these commands. So there's an at parameters, at pass parameters, and at fail parameters. You can get more info on them in the erspecs.def or from the online documentation, but basically you're going to set variable values. That's what they do. So in my case, depending on these conditionals at the time that the input event is received, we're going to change these three variables to either be off or on, 100 or 10, and then motor command times 7 or motor command times 11. So, and then we've got a delay. So this is an optional keyword, but it means that we're going to wait 1 second from when this event is triggered before we change this variable's value, 2 seconds before we change this variable's value, and 4 before we change this one. This one's going to get changed immediately. And then we're still going to have the if fail going on. So let's quickly, you can see speed GT400 is true. That's what we want it to be here. Test logical needs to be false for all this stuff to get executed. It's currently on. That means that our conditionals are going to fail, and that this is going to be executed and this is going to be executed. It doesn't matter what key switch is in, because if at least one of these fails, then the at fail parameters and at fail keywords are going to be executed. So let's do it. Let's set EV on test event 8. And so we can see down here, test event 8, this was the event that was received. And then it says the action due to test logical. Okay, so test logical was off, or was on, sorry. And so it failed to, it executed the fail stuff, or you could say it failed to execute the pass parameters due to that variable. Because this is kind of cryptic, I'll quickly detour into letting you know that there is a trace file that's updated every time event response does something. And so it's in the RAM directory, and it's called ertrace dot and then your registered name. So in my case, the registered name of this instance of event response is event response, or EVNTRESP. So you want to go to the bottom of that file, and then you'll see something much more detailed than this simple string variable. You're going to see that, let's see if I can find it. Okay, here it is. So up here is the event that was received. It was received at 12:36, a couple minutes ago, and it says that these two passed, but this one failed. So then it shows what it did. So 1 second, or 1,000 milliseconds after the event was received, test logical was set to on. Motor command would have been set to 100 millivolts. Okay, yeah, I was going to say, it says it somewhere. It says it down here. It's set to 1. I said 100, it was actually 10, because that's what's under at fail down here. And then, yeah, steam valve was set to 110 millivolts, which is motor command times 11, and motor command was set to this 2 seconds after that. So anyway, this is a more detailed explanation of what event response is doing, to briefly touch on that. So yeah, all of these fail actions were just performed. So let's make it pass. How do we make it pass? So we want speed GT400 to be true. It is. Key switch we want to be on. Currently it is. And we want test logical to be false. Currently it's on, so let's double click this on the display. Now it's off. Okay, so now I'm going to move this over here so you can see notify be immediately updated. Maybe we can see all of it. So whenever I set this event, you should see notify will update immediately because there's no delay on that. That's right here. And then you're going to see time delays on these others being updated. So you should see them update kind of sequentially on the display. So let's set this event and watch. Now this is 100. Now this is 700. And notify was updated to I did the thing immediately. I don't know if you noticed that. My terminal might have been blocking it. But yeah, so that's how that works. And yeah, here I'm updating notify to say this. Instead of at if fail, you could put notify here. You could just take this text and copy it down here and say I did not do the thing. The problem with doing that as opposed to, I mean, that might be the best thing for your use case. It depends. If you've got a lot of logical variables or a lot of conditionals up here, could be computed expressions, could be logical variables, you may want to see which one of those is causing it to not go through. A common time for this is whenever you're trying to turn your cell on and event response is not letting it because one of the many conditionals is failing and you don't know which one. So I generally like the at if fail display, even though the output is sometimes a little cryptic as we saw. It does give you the conditionals that are failing, that are causing something to not go a certain way. So yeah, hopefully that is somewhat helpful as to, you know, an insight into some of the basic things you can do with event response and how to configure them in ER specs. And yeah, how to trigger events from GP tests or from operator displays or from SetEV or limit or all kinds of different ways. So yeah, if there's any questions or comments that you have on this, if you'd like to learn more about events, let us know. If you have some tricks that I didn't mention, let us know. There's definitely more details on events that I could dig into. You know, AI transfer has special events. There's a lot of programs that have special events. Some events contain data. Yeah, I could go on for quite a while, but this video has already been going on for quite a while, so maybe we'll do more videos in the future. Let us know if you have any specific requests. Alrighty, thanks everyone.